also a generator. We are also the you can say consumer of the data. So everything here actually because every individual is generating a data and all of us are consuming a data, the volume of data is increased, right? So here if we talk about the who will generate the data, actually the first thing which you keep in your mind is the individual, because as an individual we are generating a vast data every day through our social media activity, through our online purchases, by our own mobile devices and many more things. And this data include everything from our personal preferences, from our behavior to our geographic location, our demographic information. And you can also see that nowadays there is a habit that whatever you see, whatever you do, you have to take a picture, make a video of that, which may be relevant or not relevant, but yes, there is a habit of the today's individual that he or she will do or generate a data which is may be necessary or may not be necessary. Similarly, the second type of entity which are nowadays generating a data is the organizations. Every organization of all types and sizes are generating a big data because there are various business processes include, operations are include that that need the data, and this data can be include everything from customer transactions, interactions, to supply chain and inventory management. Whatever meetings we are holding, we are recorded the meetings, and this way we are generating a data. Even this meeting is also recorded, means we are somewhere storing it and we are going to generating this data. Then the third thing is the machines. We used certain kind of machines everywhere like IoT, and it also has led to a massive increase in machine generated data. And this data is generated by you can say connected devices, sensors, which can include everything from smart appliances, wearables to industrial equipments and vehicles. Today we have automated cars, we have some kind of sensor, automated watches which can generate a data, upload the data on the cloud and process the data. So we can say overall the amount of data being generated is increasing at an unprecedented rate. Okay, so with the you can say no sign of slowing down, the data is increasing day by day, and it is very fast actually. So in fact, it is estimated that by the 2025, the world is generate 463 gigabyte of the data per day, and that is nearly 500 billion gigabytes. It is a huge or massive amount of data that are going to generated by 2025. So we can see that the big data is being generated by individuals, organizations. The format of data is changed all over around. The machines are generating a data and it is continue to grow. The challenge lies is how we can efficiently or effectively manage this data to drive the insights and to make the valuable decisions from this variety of industry and application, with some kind of you can say marketing strategies can be from this data. Okay, so this is a challenging part. So traditionally, in previous days we have the data which is generated and consumed in relatively structured manner, but nowadays because of the rise of digitization in the digitization of the world, the model is changed now, and we have now you can see the model of generating and consuming the data has undergone a significant shift from the rise of a big data. And this shift is also led to a new challenges and opportunities for the organizations, for the individuals, to work effectively to manage and analyze the vast amount of data. So we will see how important the big data is, how the big data is generated. Now there are three terms which is very much important when we study the big data, and that is volume, velocity, and variety. We will see how the kind of importance of these terms, but let me tell you about the introduction, or we can define the big data as a you can see massive and complex data set we are generating that data in very unprecedented rate, and this data is typically too large and complex which cannot be processed so easily. So for processing it, for analyzing it, which needs the traditional data management techniques cannot be used. some kind of advanced algorithm can be used. And for that we use big data analytics, right? So talking about these three V's, that is volume, velocity, and variety. The volume actually refers to the size of a big data. So we already discussed too much about the size. With the exponential growth of the data generation, we are seeing that the data are too large, which need to be processed and analyzed. And it is better if we can analyze that using some kind of traditional data management techniques, because for applying the advanced data management techniques, we need certain kind of infrastructure, which may lead to too much cost, right? So second thing is velocity, that the velocity refers to the speed of the data at which the data is being generated and that need to be processed. So with the rise of real-time data generation and processing, the individuals or organizations are must be able to handle this massive amount of data with some kind of reliable speed or incredible speed, so that we can extract the insights and in a timely manner, and then we inform the decision makers so about those insights, right? So then the third thing is the variety, which is refers to the diversity of data types, the sources that make up the big data. um, the big data can include structured data from the databases. It may have unstructured data from the social media, from the sources. We can have the semi-structured data which from various applications or hardware devices. So there is a heterogeneity in the data, diversity in the data, and this diversity and heterogeneity need to be handled when we are using big data applications. So the diversity of data type sources can make it challenging to effectively manage it, to effectively analyze it. So overall, we are talking about the three V's of big data, that is volume, velocity, and variety. We consider these as the key factors, and that define the unique challenges, opportunities that are presented by the big data as organizations uh, that work too effectively to manage and analyze this vast amount of data. It is important to keep these factors in mind and develop your strategies, your solutions that can handle them, right? So this is a main thing that we are taken into the consideration we are when we are designing our algorithms and methods to process the data. So then the what kind of tools that we are using for the big data processing. These are the some of the popular tools, like we have Hadoop, which uses MapReduce programming model. We have used PIG, Hive, Mahout, and Spark. So these are the some kind of popular tools that are using nowadays. Let me discuss or give you some brief about the uh, Hadoop, Spark, and there is one more tool nowadays we are using, Kafka. So these are the actually open source. Hadoop is an open source framework that provide distributed storage and processing capabilities for the big data applications. Actually, it is designed to handle large data sets across the cluster of the commodity hardware. Commodity hardware means any kind of computer system you can use. You make a cluster of those system, and you can divide your task into different computers so that it can be processed parallelly. Okay, so that's why it is a most popular choice of the developer to use the Hadoop architecture. Many organizations also use that because it need to process and analyze a massive amount of data in very efficient and you can say cheaper way. Next most popular the tool is a Spark. Spark is another open source framework that provides the distributed processing capabilities for big data, and it is also designed to be faster than Hadoop. Actually, it is more flexible than Hadoop with the support of multiple programming languages and a range of data sources. So, like the Hadoop has some kind of platform dependency, but in Spark we have a support of different kind of programming languages, which make it easier for accepting the larger programming community, and it also more flexible than Hadoop. That's why it is called as a flexible. And the other tool which I mentioned, but it is not mentioned here in the slide, but it is very popular nowadays. It is Kafka. Kafka is also distributed streaming platform that is used to for real-time data pipeline. We are building the real-time data pipeline, stream the, and it is also used for streaming applications. It is designed to handle large volume of data in real time, and it has become a most popular choice for the organization that also need to process and analyze the streaming data. So for those organizations, the Kafka is very important tool. So in addition to these tools, actually there are also various number of commercial big data platforms which are available. These are all the open source tools which we have discussed. In the commercial thing, we have the Amazon Web Services, AWS. We have the Microsoft Azure, which provide a range of big data services and tools for the organizations of all sizes. We can customize these tools as per our requirement, and we can use these tools accordingly. So overall, we can think that these tools actually or technologies represent some kind of most popular and widely used options for the processing of a big data. We have organizations continue to grapple with challenges of managing and analyzing the massive amount of data. It's likely that we will see even more innovative tools in near future, or more innovative technologies which may come in the years ahead, right? So the technology is innovating, so day by day a new kind of thing is evolving, and we can maybe in some years we may use some another tool which is more efficient than these. So dive into the Hadoop architecture. We will discuss the Hadoop in detail here. So let me give you some brief about how we can use Hadoop. So as we discussed, it is an open source framework for and or open source software library which provide the platform for running for distributed computations on clusters, which is built actually on a commodity hardware, and it is process it uses a MapReduce architecture, which is a programming model for processing the large data set, which runs on the top of the Hadoop, right? This is the main architecture of Hadoop. Let me give you some insight how the work things are going on when we are saying that there is a Hadoop framework which is used to perform our job in parallel scenarios. So suppose you have a data set, suppose you have some Twitter data set, you want to crawl it from Twitter, and suppose the size of the data set is 10 GB, then what you do, you have to segregate or divide your data into different blocks. We call them as a blocks, so that those blocks can be assigned to different computers. And Hadoop architecture will work on a client server model or master slave model. So how the master slave model will work? We have a master node which is also implementing the name node services, and we have different slave modes. Slave mode can be means you can make 2 slaves, 3 slaves, you can have any number of count, and the combination of master and slave is combinedly termed as a cluster. So we have a job. Suppose we have a Twitter data, and the job is to find the word count, right? So we assign this job to our cluster. Now there are different services in the Hadoop, like we can see here. A master node have a services as a name node. Slave node has a service as task tracker, data node, and map and reduce. And similarly, uh, other slave nodes also have similar services. So every services have different meaning. Like if you talking about the name node, then the name node responsibility is to divide your data, is to keep the metadata of the block. Okay, suppose your file have 15 blocks, divided into 15 blocks. Suppose we have a 10 GB of data, and we have divided it into certain kind of 64 MB of 15 blocks. Like, okay, we are just take an example for the sake of understanding. So that block, actually the metadata of that block, like for that particular block is assigned to which slave node, what is a slave node ID, what is a type of the data which is stored in that block, and what is the exact size of that block. Generally we keep the size of the block as a fixed, so that every slave, because we have the same configuration for each of the slave node, so we will assign the job equally to each of the client node or slave node, right? So where we need to assign that block is actually decided by the metadata, and that metadata information is kept inside the name node. So name node is a important service which is provided by Hadoop architecture, which is having the information about the blocks. Then we have a job tracker. Now, because for example, we are taking the job as a word count. We need to count the number of words which is appeared in a Twitter data set, right? So that job is described by the job tracker, and that job is actually assigned by job tracker to each of the slave nodes. So actually job tracker, what it do, it will assign the jobs to the maps. There are two kinds of things, map and reduce. So the map is actually perform the operations over the block which is assigned to a slave node, right? So whatever task which is provided to us, the job tracker will assign that task to the map, and map will code that task into the task tracker. Okay, so the task tracker is in communication with the map. So inside the slave node, you can see there are two boxes, one is map and one is task tracker. They have a communication with each other, and the overall information that uh, uh, कि मैप को कौन से वाला ब्लॉक एक्सेस करना है या टास्क ट्रैकर के पास कौन से वाला ब्लॉक आना चाहिए, those kind of application, those kind of metadata information is actually provided by the job tracker in the master node. So the data assignment to the data nodes is actually done by the name node, that which kind of data is there. Task assignment and to the task trackers and is actually assigned by the job tracker. Okay, so these are the two different modules or two different services which is there in the Hadoop architecture. Now everything inside the Hadoop is actually based on the Hadoop file system, that is HDFS. There is a different file system which is used by Hadoop, and this file system actually whatever we write, like जो आपका slave node काम कर रहा है, जो slave node जिसको भी process कर रहा है, the output of that process node is actually written on the HDFS, और वहां से रिड्यूसर क्या करेगा, रिड्यूसर उस डेटा को कंबाइन करके आपके रिजल्ट को आउटपुट करेगा. सो I think you got the overall idea that we have a job which is currently count of word. That job is then divided into different kinds of you can say different kinds of computers which are running the same job on individually on small chunk of data. Now it is kind of, suppose you want to population count in your area. Suppose आपको task दे दिया गया कि you have to check number of males and females in your in India. So that this overall job is to check number of males and females in India, but now the task can be divided into different states, to different you can say districts to villages and like this. Okay, so the kind of data set is reduced. The task is same. We have to analyze the number of males and females. Then we will combine those tasks and then generate the overall result. So the map service is actually divided that task into means applying that same functionality on the smaller set of data which is assigned to the slave node, and the reduce is to collect that data, right? So this is the overall architecture, and these are the same services. Like name node is a one service, data node is a service which will cap the metadata of the block which is assigned to the slave node. Map and reduce we already discussed. Job tracker and task tracker is also already discussed. So these are the things by which the master node is interacting with slave node in order to perform the task. One more important thing is the data replication. Whenever the data is divided into different chunks, it is assigned to different slave nodes. Now replication of data is kept, so that if in future suppose some kind of failure is occurred, so that in that case, because we have a copy of the data into some other slave node, the task can be is not stopped और कोई माल फंक्शन नहीं आएगा. वहीं से आपका जो रेप्लिका है वहीं पे वो क्या करेगा, जॉब ट्रैकर उसी रेप्लिका से आपका टास्क असाइन कर देगा टास्क ट्रैकर को, और रिड्यूस केवल उसी स्लेव नोड से उसका आउटकम कलेक्ट कर लेगा. दैट इज द आइडिया. Okay, so um, the slave node is also sending a echo message every after certain kind of threshold to the master node, so that the master node is able to identify कि slave node अभी सही से काम कर रहा है या नहीं कर रहा है, या उसका कोई माल फंक्शन तो नहीं आया है. So echo message हमेशा जाता रहता है, तो so that it slave node can say that okay, I am there, I am working for you, I am performing the task for you, like this. Okay, so this is the overall idea. So why this architecture is so much popular, Hadoop architecture? Because the first thing is it uses the commodity hardware. It can be implemented in any kind of system. There is no specific supercomputer which is not required here. You can scale it up, you can add a many number of system as you want, and is reliable because we have a replica of a data set, right? So every data is have a blocks, and block is stored in different slave nodes, right? So that's why Hadoop is very much popular. Because time is going to up now, I am just give you some kind of brief how the processing is done inside a file system. So we have a large chunk of file that can be divided into different splits or small chunks, and there is a record reader and a mapper. So the record reader actually do the whatever you have a input split, your record reader will read that is input split and कन्वर्ट दैट इज इनपुट स्प्लिट इनटू की वैल्यू पेयर. सो सपोज आपका ट्विटर का डेटा था, ट्विटर के डेटा को आपने रीड किया, एंड सपोज वो ट्विटर डेटा इज सेइंग दैट हाय हाउ आर यू इज अ statement or a string. Then how to convert that into a key value pair? So the one way of converting is that the number of characters or character offset is generated as a key, and the whole string is generated as a value. So the character offsets are kept as a key of the string, and the value is kept as a whole string. So this way we have a record reader which will convert your data into key value pair, which is passed to the mapper then. Okay, once you got so this way of architecture is there. We have an input data, mapper will do what it will do, it will generate a k1 a key value pair like k1 with v, k1 with v, k2 with v. And this kind of once you got this key value pair, then we can easily assign the group by key commands, which will convert that keys into a grouped architecture, so that we can able to analyze, we can able to get the frequency of the data, like how many times that particular word is appeared in our sentence. So this total program is actually done for a frequency count or word count. Then reducer will collect the input information and then return the data. So this is a overall segregated architecture. We have SDFS system in which is split into different means different parts, which is passed to the mapper. Mapper will sort it, copy that, merge it, and reducer will generate output as a part 0. Similarly, if we have different reducers, if we have multiple reducers, then different parts is generated individually. There is no combination after a reducer. Mapper will generate reducer will segregate the data, but whatever data reducer will generate, it will not be segregated further, right? So in these images, actually I am trying to explain you that once you got the output from a mapper, this will pass to the reducer, which will segregate that output, and whatever the reducer will generate, that is a final output for you. So this is a small example. Suppose we have an input the quick brown fox. Okay, so what mapper will does, it will generate the key value pair. You can see here the key value. The da is appeared one time, brown is appeared one time, fox is appeared one time. Similarly, quick is appeared one time, and similarly for all the sentences we have a mapper. Then the reducer will count the frequency of the brown. Suppose brown is taken from mapper 1 and mapper 3. Okay, mapper 3, and here is brown is appeared one time, here is also it is appeared one time. So total number of frequencies can be combined after the reducer, and brown will appear 2 times as an output. Similarly, we can do for all of the jobs. And here also for another example we have we can see the output of the frequency count. So this way each mapper is implemented by particular slave node, and that combinedly combine the outcome of each slave node, and we combine it and present it to the master node. So master node is directly interacting with HDFS, and HDFS में सारे के सारे slave nodes अपना output present कर देते हैं, and that will be accessed from the master node itself. So that is all about the HDFS file system. Now if someone have any queries, then you can ask, and that's all about the today's session. Thank you very much.
Thank you very much, Dr. Rajupal. Due to the shortage of time, we have to minimize this lecture. Otherwise, it's going to be very interesting lecture. We already enjoyed it a lot. If anyone has any questions, they may ask to Raju sir. Okay, in between, may I request you to please take some offline lecture too in the future, sir?
Sure, sir.
University.
Yes, sir. I am happy to take anytime.
Yeah, sir. I'm not finding any query from the participants side. So on the behalf of all School of Engineering and Technology, IIMT University, I, Kuldeep Singh, the coordinator of the FDP, putting forward my thanks to Dr. Rajupal sir for finding some time from their busy schedule to deliver the lecture on the topic big data in the ongoing activity. Thank you so much, sir, for the nice presentation.
Thank you, sir.
We will love to have you again.
Okay, thank you very much, sir. Thank you very much.
Most welcome, sir. Most welcome, sir. All the participants are requested to please join us in the morning, 9:15 a.m. tomorrow for the next session.